There's a place in the cosmos where the rules of reality seem to bend, where mysteries lurk in the shadows of swirling starlight, the Sombrero Galaxy. This stunning spiral of dust and suns, named for its striking resemblance to a wide-brimmed hat, holds secrets that have baffled astronomers for decades. But what if I told you that hidden within its gleaming arms lie not just one or two, but 30 bizarre objects that defy everything we thought we knew about space? These enigmatic structures don't behave like stars, planets, or even black holes. They flicker, shift, and vanish without warning, leaving scientists scrambling for answers. Picture this, a galaxy so massive it could swallow our Milky Way whole, its center glowing with the energy of 1 billion suns. Yet, it's not the sheer scale of the Sombrero Galaxy that's most astonishing, it's the oddities tucked away in its depths. Some of these objects emit radio waves unlike any known celestial bodies, while others seem to pulse with a rhythm that suggests something unnatural. Could they be remnants of ancient supernova, glitches in the fabric of space-time, or evidence of something far stranger, something beyond our current understanding? This is more than just a story about distant lights in the sky. It's a journey into one of the universe's most perplexing puzzles, a chance to stand on the edge of discovery and peer into the unknown. Over the next few minutes, we'll unravel the clues, explore the theories, and confront the chilling possibility that these 30 objects might rewrite the textbooks. So buckle up, because what lies ahead isn't just science. It's a glimpse into the cosmic unknown, and it's waiting for us right now in the heart of the Sombrero Galaxy. The first of these 30 cosmic oddities is perhaps the most visually striking. A ghostly, twisting ribbon of light known as the Phantom Spiral. Unlike the neat, predictable arms of the Sombrero Galaxy itself, this structure spirals erratically, as if painted across the void by an invisible hand. Gravitational forces should have torn it apart eons ago, yet there it hangs, defying the laws of physics with eerie persistence. At first glance, it resembles a smaller galaxy caught in the act of being swallowed by the sombrero. Except there's no core, no cluster of stars at its center to explain its cohesion. Instead, it's just a thread of glowing gas and dust winding through space like a cosmic afterthought. What makes it even stranger is its movement. Most spiral structures orbit predictably, bound by the gravity of their host galaxy. But the Phantom Spiral drifts against the current, its motion out of sync with everything around it. Astronomers have thrown every possible explanation at this celestial rebel. Could it be the shattered remains of a dwarf galaxy, stretched into this bizarre shape by tidal forces, or perhaps a shockwave from some cataclysmic event frozen in time? The leading theory involves dark matter, an unseen, mysterious substance thought to weave through the universe. Some suggest the spiral might be tracing the contours of a dark matter filament, an invisible skeleton shaping its path. But even that doesn't fully explain its unnatural stability. Then there's the light it emits. Instead of the steady glow of starlight, the Phantom Spiral flickers unpredictably, as though something hidden within it is switching on and off. Some researchers speculate it could be a graveyard of dead stars, their remnants interacting in ways we've never witnessed. Others whisper about more exotic possibilities, cosmic strings, theoretical defects in spacetime itself, left over from the birth of the universe. Whatever it is, the Phantom Spiral refuses to fit into any neat category. It's a cosmic question mark, a reminder that even in a galaxy as well studied as the Sombrero, the universe still has tricks up its sleeve. And this is just the first of 30 enigmas waiting to be unraveled. Deep in the heart of the Sombrero Galaxy, where stars crowd like fireflies around a cosmic bonfire, astronomers stumbled upon something that shouldn't exist, not one, but two supermassive black holes locked in a gravitational dance. Most galaxies, including our Milky Way, host a single colossus at their core. But here, these titans whirl around each other in a slow, deadly waltz, separated by less than the distance from our Sun to Pluto. Their discovery shattered expectations and opened a new chapter in our understanding of how galaxies collide, merge, and evolve. Think of it like a cosmic car crash in extreme slow motion. When galaxies collide, their central black holes eventually spiral toward one another, drawn by gravity. But for them to get this close, just a few light years apart without merging defies the odds. Normally, friction from gas and stars would nudge them together over time. Yet these two stubborn giants refuse to coalesce, circling each other for what may be billions of years. Scientists call this a stalled merger, and the Sombrero's duo is one of the clearest examples ever found. The implications ripple far beyond this single galaxy. Binary black holes like these are thought to be the engines behind some of the universe's most violent phenomena. As they orbit, they warp space-time, sending out ripples known as gravitational waves, echoes of their motion that detectors like LIGO have only begun to trace. But here's the twist: the Sombrero's pair is unusually quiet. Unlike the chaotic X-ray bright duos seen elsewhere, these black holes emit almost no radiation, as if they've agreed to a truce. Some researchers suspect they've already cleared their vicinity of stars and gas, leaving them in eerie, empty isolation. The real mystery lies in their origins. Did the Sombrero Galaxy cannibalize a smaller neighbor, absorbing its black hole in the process? Or was this galaxy born from the merger of two equally massive predecessors, their cores persisting as a matched set? Clues hide in the galaxy's unusual structure, its thick dust lanes and oddly distributed star clusters which bear the scars of ancient collisions. But one thing's certain: this discovery challenges the textbook narrative of galaxy formation. If binary black holes are more common than we thought, it could mean the universe is far messier, far more dynamic than our models predicted. And then there's the question of what happens next. Eventually, these black holes will collide, releasing energy equal to 100 million supernovae in a single space-time shattering blast. Until then, they offer a front-row seat to one of the universe's rarest spectacles, a pair of cosmic predators forever circling, forever waiting. But the Sombrero Galaxy isn't done surprising us, because just beyond these two giants, another enigma waits, one that pulses with a rhythm no scientist can yet explain. Not far from the dueling black holes, something even more bewildering floats in the cosmic haze, a nebula that shouldn't glow this brightly. Most nebulae are stellar nurseries or graveyards, lit by the gentle light of nearby stars or the fading embers of dead ones. But this one, dubbed the Radiant Anomaly, burns with an intensity that defies all known energy sources. Its eerie blue-white glow pulses irregularly, like a beacon signaling from the depths of space, and the radiation it emits doesn't match any known element or process in our astrophysical playbook. At first, astronomers assumed it was just another star-forming region, energized by newborn suns. Yet closer inspection revealed something far stranger. The nebula's light spectrum contains spikes of energy at wavelengths never seen in nature, lines that don't correspond to hydrogen, helium, or any of the usual cosmic suspects. It's as if the nebula is running on an entirely different kind of physics. Some researchers have even joked that it looks like a malfunctioning alien power plant, though the truth is likely both more mundane and more profound. The leading hypothesis involves an exotic form of decay. Deep within the nebula's swirling clouds, particles of an unknown, unstable element might be breaking apart, releasing energy in bursts we've never catalogued. Others suggest it could be a concentrated pocket of dark matter, annihilating itself in quiet, invisible collisions that leave behind this radiant signature. Then there's the wildcard theory. What if this nebula is the aftermath of a star that didn't just die but transformed? Certain hyper-advanced civilizations, theoretically, could manipulate dying stars into energy sources, though that's a speculation bordering on science fiction. What's undeniable is the nebula's structure. Unlike the chaotic clouds of typical nebulae, this one has near-perfect geometric filaments, as if sculpted by magnetic fields 1,000 times stronger than anything we've measured. These filaments pulse in unison, hinting at some synchronized internal clock, and at its core, a void. No central star, no black hole, no visible engine to power the spectacle. Just silence wrapped in a storm of impossible light. The radiant anomaly forces us to confront how much we still don't understand about energy in the universe. It's a reminder that even the most familiar cosmic phenomena can hide secrets, and that the Sombrero Galaxy isn't just a collection of stars. It's a gallery of cosmic riddles, each more perplexing than the last. And as we peel back the layers of this luminous mystery, the next object on our list waits in the shadows, a cluster of stars moving backwards against the galaxy's spin, as if time itself has reversed around them. Nestled among the swirling arms of the Sombrero Galaxy, there's a group of stars that plays the ultimate game of cosmic hide and seek. Astronomers first spotted this cluster, dubbed the Vanishing Act decades ago, blinking into view during one observation, only to disappear without a trace the next time they looked. It wasn't a glitch in the telescopes or a trick of the light. This cluster genuinely fades in and out of existence, defying every rule we know about how stars behave. At its brightest, the Vanishing Act resembles a typical globular cluster, a dense sphere of ancient stars bound together by gravity. But here's where things get weird. Most clusters like this are stable for billions of years, their light constant and predictable. This one, though, flickers on and off like a faulty street lamp, sometimes vanishing for months or even years before reappearing in the exact same spot. The first time it happened, scientists assumed it was a technical error until it kept happening again and again across multiple observatories. So what's causing this celestial disappearing act? One leading theory points to gravitational lensing, a phenomenon where the gravity of a massive object, like a black hole or dark matter clump, bends light around it, magnifying distant stars like a cosmic magnifying glass. If such an object were drifting between us and the cluster, it could warp our view, making the stars temporarily visible before fading as the lens moves away. But there's a catch. Lensing usually distorts or smears the light, whereas this cluster appears perfectly intact each time it returns. Another possibility is far more unsettling. Some researchers speculate the cluster might not be made of stars at all, but of something else entirely, a swarm of artificial megastructures, perhaps, designed to harvest energy or communicate across vast distances. The idea echoes the hypothetical concept of a Dyson sphere, a civilization-scale project to capture a star's power. If such structures were arranged in a cluster-like formation, their sporadic alignment with Earth could explain the erratic visibility. It's a fringe theory, but the absence of telltale heat signatures or radio waves leaves even skeptics scratching their heads. Then there's the timing. The Vanishing Act doesn't disappear randomly. Its vanishings follow a loose, chaotic rhythm, almost as if it's responding to an unseen force. Could it be orbiting something invisible, like a rogue black hole or a knot of dark matter, its light snuffed out periodically by the object's shadow? Or is there a simpler explanation, a dense cloud of interstellar dust drifting in and out of the line of sight, acting like a cosmic curtain? The truth is, we're still grasping at cosmic straws. Every time astronomers think they've pinned down an answer, the cluster throws another curveball. Its reappearances don't match any known natural cycle, and its light spectrum shows no signs of the dimming or reddening typical of obscured objects. It's as if the universe is teasing us with a puzzle it refuses to solve, and that's what makes the Vanishing Act so tantalizing. It's not just a scientific curiosity, it's a challenge to our very understanding of reality. Whether it's a trick of physics, a shadow play of dark matter, or something even more extraordinary, one thing's clear: the Sombrero Galaxy holds mysteries that refuse to stay neatly in their boxes. And as we turn our gaze deeper into its starry depths, the next enigma is already waiting, a void so empty, it's as if a piece of the universe itself has been erased. Among the swirling dust lanes and glittering stars of the Sombrero Galaxy, one object stands apart, not for what it does, but for what it appears to be. Suspended in the void like a discarded cosmic artifact, the metallic ring is a perfect, unbroken circle of what seems to be polished metal, floating untethered in space. Stretching nearly 200,000 miles in diameter, wide enough to span the distance from Earth to the Moon with room to spare, its surface reflects starlight with an eerie, mirror-like precision. At first glance, the ring looks like something straight out of science fiction, a structure so geometrically flawless, so unnaturally smooth, that it's hard to believe it formed without intervention. Most cosmic rings, like the debris around Saturn or the glowing hoops of supernova remnants, are chaotic, uneven things, but this looks engineered. Spectrographic analysis only deepens the mystery. The ring's composition defies classification, with elements arranged in alloys not found anywhere else in nature. Some portions even appear to be layered in a way that suggests deliberate manufacturing, like the strata of a forged blade. The debate among astronomers is fierce. On one side, researchers argue it could be a freak result of extreme astrophysical processes, perhaps the remnants of a shattered neutron star, its crust compressed into this bizarre shape by magnetic fields beyond comprehension. Others point to the ring's bizarre stability. Unlike natural structures which degrade over time under cosmic radiation and micrometeorite impacts, this object shows no signs of weathering. It's as if it's being maintained or protected. Then there's the orbit. The ring drifts lazily around the Sombrero's core, but its path doesn't follow the expected curve of gravitational mechanics. It corrects itself with tiny, precise adjustments, almost like a spacecraft maintaining position. No known natural phenomenon accounts for this behavior, leading a vocal minority to propose the unthinkable. Could this be evidence of astroengineering? A relic of some ancient civilization's technology, left behind for reasons we can't fathom. Skeptics counter that the universe is vast enough to produce outliers beyond our current models. They cite the bizarre hexagonal storm on Saturn or the perfectly rectangular icebergs spotted in Earth's oceans as proof that nature occasionally drafts straight lines. But even they struggle to explain the ring's most unsettling feature, its silence. It emits no radio waves, no heat signatures, no energy pulses, just that cold, mirror-like surface, reflecting the galaxy back at itself like a question waiting to be answered. The metallic ring forces us to confront the limits of our understanding. Whether it's a cosmic coincidence or something more profound, it stands as a humbling reminder that the universe is capable of crafting mysteries we're only beginning to glimpse. And as we turn away from its gleaming surface, the Sombrero Galaxy has already prepared another enigma, a star that doesn't just burn but sings. Amid the chaos of the Sombrero Galaxy's swirling arms, two celestial bodies glide through the void with uncanny precision, the Mirror comets. These icy wanderers don't just share the same orbit, they move in flawless lockstep, their paths tracing identical curves through space as if connected by an invisible thread. What makes them truly extraordinary, though, is their surfaces polished to a mirror-like sheen, reflecting starlight with such precision that they appear less like cosmic rubble and more like silver marbles hurled across the galaxy. Most comets are ragged, pockmarked things, their icy nuclei clumped with dust and organic compounds, but the Mirror comets defy convention. Their exteriors are eerily smooth, lacking the cracks and craters typical of objects battered by eons of space debris. Spectroscopic readings reveal another oddity. Their surfaces are layered with metallic alloys, including elements like iridium and osmium materials far denser and rarer than the usual cocktail of frozen gases found in ordinary comets. It's as if someone or something dipped these comets in liquid metal and let them harden under the cold gaze of deep space. Then there's their motion. Gravitational forces should have pulled them apart long ago, or at least nudged them into slightly divergent paths. Instead, they maintain their synchronized dance with millimeter precision, never straying more than a few hundred kilometers from one another. Computer simulations struggle to replicate this behavior without introducing an unseen force, some kind of tether or energy field keeping them aligned. One theory suggests they're trapped in a mutual gravitational resonance, a delicate balance where each comet's pull corrects the other's trajectory. But even that explanation falls short, as their movements lack the subtle wobbles such a system would produce. Perhaps the most unsettling detail is their silence. Normally, comets vent gases as they warm, creating glowing tails of ionized particles. These too, though, emit nothing. No outgassing, no plasma trails. They're dark, sleek, and utterly inert, gliding through the void without the usual fanfare of evaporation. Some researchers speculate their metallic shells might act as shields, sealing volatile ices beneath an impenetrable outer layer. Others wonder if they're not comets at all, but fragments of some larger engineered structure, a broken ring or spacecraft hull, cast adrift and polished smooth by millennia of microscopic impact. The mirror comets challenge our assumptions about how objects behave in space. They're too coordinated to be random, too pristine to be natural, and too bizarre to ignore. Whether they're cosmic coincidences or clues to something deeper, one thing's certain. In a galaxy already brimming with anomalies, these twin enigmas remind us that the universe still holds mysteries we're only beginning to glimpse. And as we turn our gaze deeper into the Sombrero's heart, the next puzzle awaits. A star cluster that doesn't just orbit the galaxy's center, but mimics it like a shadow dancing in sync with its master. Tucked away in the outer reaches of the Sombrero Galaxy, drifting silently through the darkness, lies an object that redefines what a planetoid can be. At first glance, it appears unremarkable, a roughly spherical body about the size of Earth's moon, pocked with craters and bathed in the faint glow of distant starlight. But when astronomers trained their instruments on this wandering worldlet, they uncovered something impossible. It's completely hollow, not partially excavated, not honeycombed with caves, but an empty shell, its interior a perfect void. The discovery sent shockwaves through the scientific community. Planetary bodies simply don't form this way. Gravity dictates that cosmic debris clumps together into dense balls of rock and metal, compressing under their own weight until they become solid through and through. Yet this object defies that fundamental rule, its crust unnaturally thin for its size, resonating like a cosmic bell when nudged by passing asteroids. Theories about its origin range from the extraordinary to the downright eerie. One camp argues it could be the fossilized remnant of an ancient collision, a catastrophic impact between two protoplanets that vaporized their cores, leaving only the outer layers fused into this fragile husk. Others suggest a more exotic process, perhaps a rogue black hole or neutron star passed through its center long ago, stripping away the interior matter with gravitational precision while leaving the surface intact. There's even a fringe hypothesis involving antimatter annihilation, where a trapped pocket of the substance met its ordinary counterpart in a slow, controlled burn that hollowed the world from within over millennia. Then there's the unsettling alternative that it wasn't natural forces at all. The planetoid's shell shows peculiar uniform thickness, its inner surface suspiciously smooth in ways that erosion can't explain. Could it be the abandoned megastructure of some long-vanished civilization? A storage vault, a habitat, or even a propulsion device repurposed from some unimaginable technology? Skeptics point out that the energy required to excavate an entire world would dwarf anything humanity has ever produced. Yet the object's orbit adds another wrinkle. It doesn't follow the elliptical path typical of captured asteroids, but moves with deliberate, almost circular precision around the galaxy's outskirts, as if parked there intentionally. Perhaps the most haunting detail is the silence. Probes sent to study the planetoid detect no seismic activity, no magnetic field, no residual heat from radioactive decay, just stillness. When lasers were bounced off its surface to map its interior, the echoes returned too quickly, confirming the emptiness within. It's as if the universe carved out this pocket of nothingness just to remind us how much we still don't understand. Whether a freak accident of physics or something far more deliberate, the hollow planetoid challenges our assumptions about how worlds are born and what they're meant to be. And as we piece together the clues scattered across the Sombrero Galaxy, one thing becomes clear. Some mysteries aren't just waiting to be solved, they're waiting to rewrite the rules entirely. Hanging in the depths of the Sombrero Galaxy, pulsing with the precision of a cosmic metronome, is an object that blurs the line between natural phenomenon and deliberate transmission. Known as the radio pulse beacon, it emits bursts of radio waves at intervals so regular, so mathematical, that when astronomers first detected them, they had to double-check their instruments. Unlike the chaotic static of quasars or the erratic flickers of magnetars, these pulses arrive like clockwork every 73 minutes without fail, each burst lasting exactly 12 seconds before vanishing back into silence. At first, scientists assumed it was a pulsar, one of the universe's natural lighthouses. These dense neutron stars rotate rapidly, sweeping beams of radiation across space like a spinning spotlight. But pulsars slow down over time, their rhythms decaying as they lose energy. The beacon defies this rule. Its pulses haven't wavered in decades, maintaining the same interval down to the millisecond, a stability that borders on artificial. Even stranger, the pulses aren't random noise. When analyzed, they form repeating patterns that resemble packets of information, clusters of peaks and troughs that some researchers argue could be structured data. This is where the story takes a turn toward the extraordinary. SETI, the search for extraterrestrial intelligence, has scrutinized the beacon's signals for years, running them through every decryption algorithm in their arsenal. While no one's claiming it's a message from aliens, the patterns resist easy explanation. Natural cosmic signals tend to be messy, shaped by magnetic fields and plasma turbulence. These pulses, though, are clean, with harmonics that suggest intentional modulation. Some scientists compare them to the early days of human radio, when we first learned to encode voices and images into electromagnetic waves. Of course, there are natural candidates. One theory proposes an ultra-rare binary system, a neutron star locked in orbit with a black hole. Their gravitational dance, creating precise energy, releases as the star's magnetic field snaps and reconnects. Another suggests a so-called nulling pulsar, a type of neutron star that temporarily shuts off its emissions, though none observed elsewhere match the beacon's impeccable timing. Then there's the wild card, a macroscopic quantum object, a crystal-like structure light years across, vibrating at frequencies that generate these radio bursts like a tuning fork struck by the universe itself. But the most haunting possibility isn't a what, it's a when. The beacon's signals take roughly 29 million years to reach Earth. If they are artificial, their senders might have vanished long before the first dinosaurs walked our planet. Their message, if it is one, could be a fossil of a civilization that flared bright and faded eons ago, its very existence reduced to this rhythmic whisper across the cosmos. Whether natural or not, the radio pulse beacon forces us to confront a humbling truth. The universe is capable of crafting phenomena so precise, so orderly, that they mirror the products of intelligence. And in that ambiguity lies a thrill deeper than any answer, the chance to stand at the edge of discovery, listening to a pulse that might be physics at its most sublime or something far more profound. As if to underscore the Sombrero Galaxy's penchant for mystery, Our next object doesn't just defy expectations, it inverts them. A star cluster where the laws of motion seem rewritten, where hundreds of suns orbit backward against the galaxy's spin, as if time itself flows in reverse around them. High above the Sombrero Galaxy's swirling core, suspended in the cold embrace of interstellar space, drifts a spectacle that seems plucked from the realm of fantasy, a vast, shimmering cloud not of gas or dust but of diamonds. The Diamond Storm Cloud, as astronomers have dubbed it, glitters with trillions of microscopic crystalline particles, each one a perfect lattice of carbon forged under conditions so extreme they defy earthly imagination. Unlike ordinary cosmic clouds which glow faintly with reflected starlight, this one scatters light in sharp, prismatic bursts, as if someone had scattered a handful of crushed gemstones across the void. The reason, these aren't just carbon clumps, they're genuine diamonds, some no larger than grains of sand, others as big as boulders, all tumbling silently through the darkness. For such a structure to exist, the universe had to orchestrate a perfect storm of physics. First, the temperature. Diamond formation requires unimaginable heat and pressure, the kind found deep inside gas giants or the hearts of dying stars. Here, though, there's no planet or star to provide that crushing force. Instead, researchers believe the cloud is the ghostly aftermath of a white dwarf's death throes. A once mighty star that shredded itself apart in a supernova, compressing its carbon-rich outer layers into diamond shards in the process. The explosion's shockwave would have acted like a cosmic hammer, slamming atoms together with enough force to rearrange them into crystalline perfection. Second, the cold. Diamonds might form in heat, but they survive in cold. The cloud drifts through one of the galaxy's most frigid regions, where temperatures hover just a few degrees above absolute zero. In this deep freeze, the crystals don't vaporize or degrade. They linger, suspended in a near-perfect vacuum, their structures preserved for eons. But the real mystery isn't how the diamonds form. It's why they haven't collapsed into a planet or been swallowed by nearby stars. Most cosmic debris clumps together over time, drawn by gravity into larger bodies. This cloud, though, remains stubbornly diffuse, its particles repelling one another with faint electrostatic charges or perhaps caught in an invisible magnetic web. Some astronomers speculate that dark matter might be at play, its gravitational influence subtly balancing the cloud against collapse. Others wonder if the diamonds are younger than we think, continuously replenished by some ongoing process we've yet to detect. Then there's the light. When certain stars shine through the cloud, their spectra reveal something bizarre, missing wavelengths as if the diamonds are selectively filtering the light. This isn't just refraction, it's absorption, a sign that the crystals might be doped with trace elements like nitrogen or boron, altering their optical properties in ways never seen in natural space diamonds. Could these impurities hint at the cloud's origins, or are they evidence of some far stranger chemistry at work? The diamond storm cloud is more than a cosmic curiosity. It's a laboratory for extremes, a place where the universe bends its own rules to craft something both beautiful and baffling. Whether a fleeting accident or a permanent fixture of the Sombrero Galaxy, one thing's certain: it reminds us that even the most exotic treasures on Earth are mere shadows of what the cosmos can create. And as we turn our gaze deeper into the galaxy's mysteries, the next anomaly awaits a star that doesn't just burn, but breathes, its light rising and falling like the chest of a sleeping giant. Looming against the star-studded backdrop of the Sombrero Galaxy, two colossal slabs of darkness glide silently through the void, the floating monoliths. Each stretches nearly 1,000 kilometers in length, their razor-straight edges and flat, featureless surfaces so unnaturally geometric, they look less like cosmic rubble and more like deliberate constructs. If you've ever seen 2001: A Space Odyssey, the resemblance is chilling. But unlike Kubrick's fictional Monolith, these aren't the work of some advanced intelligence, at least not as far as we can prove. The first mystery is their composition. spectrographic scans bounce back with bizarre readings, a dense amalgam of metals and minerals, including titanium, tungsten, and even traces of osmium, one of the heaviest elements in the universe. These materials don't typically clump together in nature. They're more commonly found in planetary cores or scattered thinly across asteroid belts. Yet here they are, fused into these monolithic slabs with an almost manufactured precision. Some scientists argue they could be fragments of a shattered super-Earth, a rocky planet torn apart by gravitational forces, its core sliced cleanly and ejected into space. But even that theory struggles to explain their perfect right angles. Natural forces tend to create chaos, not symmetry. Then there's their motion. The monoliths drift side by side, maintaining a fixed distance of roughly 5,000 kilometers between them, as if locked in some silent, synchronized march. They don't spin or tumble like ordinary asteroids. Their orientation remains constant, always presenting the same broad face to the galaxy's core. This stability is unheard of for free-floating objects of their size. Most cosmic debris gets nudged by stellar winds, radiation pressure, or passing gravitational fields. Yet these structures move with eerie precision, their paths unerringly straight. The debate over their origins splits the scientific community. One camp insists they're the remnants of an ancient collision, a freak accident where two planets side-swiped each other at just the right angle to shear off these jagged fragments. Others point to the monolith surface textures unnaturally smooth in places, with what appear to be layers like sedimentary rock forged under extreme pressure. Could they be splinters from a long-dead neutron star's crust, ejected during a cataclysmic merger? But it's the fringe theories that capture the imagination. A vocal minority suggests these might be relics of a bygone civilization's engineering cosmic signposts, navigation aids, or even dormant spacecraft. After all, their dimensions align suspiciously close to the silver ratio, a mathematical constant found in advanced structural design. And then there's the silence. Unlike most metallic objects in space, the monoliths emit no thermal signatures, no magnetic fields, no residual radiation. They're dark, cold, and utterly inert, as if deliberately designed to avoid detection. Whether shattered planetary ruins or something far more enigmatic, the floating monoliths stand as a stark reminder. The universe doesn't always play by the rules we've written. And as we peer deeper into the Sombrero's secrets, the next anomaly defies logic in an even more unsettling way. A nebula that doesn't just glow, but thinks, its gases pulsing in patterns eerily reminiscent of neural networks. Deep within the Sombrero Galaxy's spiral arms, a planet glows with a light all its own, a gas giant so luminous it outshines some of the stars around it. Dubbed the Bioluminescent Titan, this world defies every expectation of what a gas giant should be. Unlike Jupiter or Saturn, which merely reflect sunlight, this colossal sphere generates its own ethereal radiance, a pulsating, living light that shifts between hues of electric blue and deep violet, as if breathing in the darkness. At first, astronomers assumed the glow came from auroras. The same mesmerizing light shows that dance over Earth's poles when solar winds collide with our magnetic field. But the Titan's light behaves differently. It isn't confined to the poles. It ripples across the entire planet in slow, rhythmic waves, like the luminescent tides of some alien ocean. Even stranger, the light pulses aren't random. They follow patterned cycles of brightening and dimming that repeat with uncanny regularity, almost like the planet has a heartbeat. So what's powering this cosmic lighthouse? One possibility lies in the planet's atmosphere. Gas giants are typically shrouded in swirling clouds of hydrogen and helium, but the Titan's upper layers are laced with exotic compounds, phosphorescent gases like those found in deep-sea organisms on Earth. Under the right conditions, these gases could theoretically absorb energy from the planet's turbulent core and re-emit it as light, creating a planet-wide bioluminescent display. Some researchers speculate the planet might harbor floating, microbial-like life forms in its upper atmosphere, organisms that generate light as a byproduct of their metabolism, similar to Earth's fireflies or glowing plankton. Then there's the wildcard theory. The Titan might be undergoing chemical reactions we've never seen before, deep in its crushing atmosphere where pressures exceed 1,000 times Earth's sea level. Familiar elements could behave in bizarre ways. Hydrogen might form crystalline lattices, or helium could bond with metals under extreme conditions, creating compounds that emit energy as light. The planet's magnetic field, unusually strong for a gas giant, could act as a catalyst, stirring these reactions into a self-sustaining loop. But the most tantalizing clue lies in the light's patterns. When analyzed, the pulses contain subtle variations, tiny deviations in timing and intensity that resemble coded signals. SETI scientists have spent years parsing these fluctuations, searching for evidence of intentional structure. So far, no definitive message has emerged, but the mere possibility raises profound questions. Could the Titan be more than a natural wonder? Could it be a beacon, a cosmic alarm, or even, dare we say it, a form of planetary-scale communication? The bioluminescent Titan challenges us to rethink the boundaries of life and chemistry. Whether it's a canvas for unknown physics, a haven for floating organisms, or something even stranger, one thing is certain. In a universe full of blazing stars, this glowing giant stands apart, a world that doesn't just bask in light but creates it. And as we turn our gaze deeper into the Sombrero's mysteries, the next anomaly defies explanation in an even more unsettling way. A star that doesn't just shine but sings, its vibrations echoing across the cosmos like a celestial symphony. In the heart of the Sombrero Galaxy, where gravity bends light like a funhouse mirror, there's a place where time itself seems to stutter, a swirling maelstrom of distorted spacetime known as the Time-Dilation vortex. Clocks here don't tick the way they should. Probes sent into its periphery return with timestamps that don't match mission control's records, their onboard systems lagging seconds, then minutes behind, as if trapped in a cosmic slow-motion reel. But this isn't just a glitch in the machinery. It's a real-world demonstration of Einstein's wildest predictions, where the fabric of the universe stretches thin enough to warp the very flow of time. The vortex behaves like no other gravitational anomaly we've seen. Normally, time dilation occurs near massive objects like black holes, where gravity's grip is so strong that seconds crawl compared to those in open space. But here, the effect is stronger than current physics can explain, far beyond what the visible mass in the region should produce. Telescopes trained on the vortex reveal stars orbiting its edges in bizarre, slow-motion spirals, their light stretched into redder, longer wavelengths as they struggle against the drag of distorted time. One star, observed over a decade, appeared to take 20 years to complete a single orbit, an impossibility unless time itself was being stretched like taffy. The leading theory involves dark matter specifically, a concentrated knot of it spinning at relativistic speeds, its invisible mass twisting space-time into knots. Picture a whirlpool in water, but instead of liquid, it's the dimensions of reality being pulled into a vortex. Some models even suggest the vortex could be a natural particle accelerator, where dark matter collisions generate exotic energies that further warp the area. But there's a tantalizing alternative: wormholes. The vortex's time-slowing effects align with theoretical predictions for a stable wormhole's mouth, a tunnel through space-time that hasn't collapsed into a singularity. If true, this could be a backdoor to another part of the universe or another time. What makes the vortex truly unsettling, though, is its silence. Most cosmic anomalies emit some form of radiation: X-rays, gamma rays, radio static. This one is eerily dormant, as if the laws of physics themselves are being muffled within its grasp. Even light passing through it dims, not from absorption, but from time dilation. The photons arriving at our telescopes stretched thinner, their energy sapped by the vortex's grip. Could this be a gateway to the unknown, a cosmic accident, or something else entirely? The Sombrero Galaxy's time-dilation vortex doesn't just challenge our understanding of gravity. It dares us to rethink what's possible in a universe where time, it seems, is anything but constant. And as we pull our gaze away from this temporal enigma, the next object waits, a cluster of stars that don't just burn, but whisper, their light-carrying patterns that look suspiciously like language. Drifting silently through the Sombrero Galaxy's outer reaches, an unassuming asteroid hums a melody no human ear can hear, but our telescopes can. Unlike the usual silent rocks tumbling through space, this one, dubbed the Singing Asteroid, emits a constant stream of harmonic sound waves, vibrating at frequencies so precise they form what scientists describe as a cosmic chord. Converted into audible tones, the sound resembles the eerie, resonant hum of a glass harp, a single, unwavering note that lingers in the void. At first, astronomers dismissed the phenomenon as electromagnetic interference. But when multiple observatories confirmed the same acoustic pattern emanating from the asteroid's surface, the truth became undeniable. This rock was singing. The sound isn't carried through space. Sound waves can't propagate in a vacuum, but through fluctuations in the asteroid's magnetic field, pulsing in rhythmic cycles that match the harmonic frequencies. It's as if the asteroid is a colossal tuning fork, struck by some unseen force and left to vibrate across the eons. So what's causing this celestial serenade? The leading theory points to resonant frequency. Every object has a natural vibrational frequency, a pitch at which it wants to oscillate when disturbed. On Earth, we see this when a wine glass shatters at the right note. For the singing asteroid, its composition, likely a dense alloy of iron and nickel, acts like a bell, resonating when bombarded by solar winds or micrometeorites. But here's the catch: most metallic asteroids don't sustain these vibrations. They dampen out quickly, their energy dissipating as heat. This one, though, persists, its tone unwavering even when external forces change. That's where the magnetic field comes in. Spectrographic scans reveal the asteroid is crisscrossed with swirling bands of magnetized minerals, creating a dynamic shield that interacts with charged particles from nearby stars. As these particles whip past, they excite the magnetic field, which in turn transfers energy back into the asteroid's structure, a self-sustaining feedback loop that keeps the song alive. It's a natural amplifier, turning the asteroid into a cosmic theremin. But not everyone's convinced it's purely natural. The harmonies are too precise, the frequencies too perfectly spaced to dismiss as random. Some researchers have noted eerie similarities to the resonant frequencies used in quantum experiments on Earth, where vibrations can manipulate particles at the atomic level. Could the asteroid's song be an accident of physics or a remnant of some long-lost technology designed to harness these very frequencies? Skeptics argue that Occam's razor favors natural explanations, but even they admit the galaxy has thrown us stranger curveballs. Then there's the silence around it. The singing asteroid orbits alone, no companion rocks or debris to explain its unique properties. It's as if the universe placed it there deliberately, a single note held against the cosmic silence. Whether a quirk of magnetism or a message encoded in vibration, one thing's clear: in a galaxy teeming with unexplained phenomena, this humble asteroid proves even the smallest objects can hold the grandest mysteries. And as its haunting frequencies ripple outward, they carry a reminder sometimes: the universe doesn't just show us its wonders, it sings them. Among the countless wonders of the Sombrero Galaxy, few sights are as deliberately arranged or as unsettlingly precise as the Triangulum ships. These three triangular objects glide through the void in perfect formation, their movements synchronized down to the second, as if executing some grand cosmic choreography. Each massive structure spans nearly twice the length of Earth's tallest mountains, their smooth, metallic surfaces reflecting starlight with an almost artificial sheen. What makes them truly extraordinary, though, isn't just their shape, it's the way they move. Unlike asteroids or comets, which follow the lazy arcs of gravity, these objects maneuver with purpose, adjusting their trajectories in unison like a squadron of celestial jets. The formation itself is a geometric marvel. The three ships, if that's what they are, maintain an equilateral triangle at all times, the distance between them never varying by more than a few kilometers, even during sharp directional changes. This kind of precision is unheard of in natural cosmic objects. Most space debris tumbles chaotically, influenced by random gravitational tugs or collisions. But the Triangulum ships correct their positions with minute thruster-like bursts, their paths intersecting in patterns that resemble pre-programmed flight plans. Telescopes have even captured them executing complex maneuvers, sudden 90-degree turns, synchronized spirals, even abrupt halts, all without the telltale debris clouds or energy signatures of conventional propulsion. So how are they moving? The leading theory involves magnetic sails, hypothetical propulsion systems that harness the galaxy's magnetic fields like invisible highways. Instead of burning fuel, these ships might ride cosmic forces, using superconducting hulls to repel or attract ambient magnetic energy. It's a concept humanity has theorized for interstellar travel, but never observed in nature. Yet the Triangulum ships' movements fit the profile eerily well. Their course corrections align with magnetic field fluctuations in the Sombrero Galaxy, and their metallic composition could theoretically interact with those fields. Some researchers even speculate their triangular shape isn't accidental, that the geometry maximizes surface area for magnetic manipulation, turning each ship into a sort of cosmic surfboard riding waves of invisible force. Then there's the unsettling alternative that they're not natural at all. The ship's formation flying mirrors military drone swarms or satellite arrays, their behavior suggesting not just coordination but communication. If they're artificial, their purpose is anyone's guess. Autonomous probes from a long-dead civilization, sentinels monitoring the galaxy, or something more enigmatic like von Neumann machines, self-replicating explorers designed to map the cosmos. Skeptics point to natural precedents, like the way certain crystals grow in geometric patterns or flocking birds maintain formation through simple rules. But even those examples pale next to the ship's flawless, energy-efficient precision. The most haunting detail, though, is their silence. Despite their obvious energy expenditure, the Triangulum ships emit no heat, no radiation, no engine glow. They're dark, cold, and utterly self-contained, as if designed to avoid detection. Whether drones, natural oddities, or something beyond our understanding, one thing's certain. In a galaxy brimming with mysteries, these three silent travelers remind us that the line between the cosmic and the constructed may be thinner than we think. And as their perfect triangle glides deeper into the Sombrero's heart, the next enigma waits, a nebula that doesn't just drift but computes, its swirling gases arranging themselves into patterns uncannily like neural networks. Nestled between the arms of the Sombrero Galaxy, hidden within a cloud of glittering interstellar dust, lies a structure so intricate it seems handcrafted by the universe itself, the quantum fractal. At first glance, it resembles a snowflake magnified a billion times, its delicate branches spiraling outward in ever smaller repetitions. But this is no ordinary cosmic ice crystal. Peer closer, and the fractal's patterns don't just repeat, they scale down, maintaining perfect geometric symmetry all the way to the quantum level, where atoms arrange themselves into miniature copies of the larger whole. It's as if someone took a mathematical concept and forged it into physical reality. What makes this fractal truly extraordinary is its behavior. Most natural fractals, like coastlines or fern leaves, are statistical, their patterns approximate. This one is exact. Its branching angles repeat with mathematical precision, and its layers interact in ways that defy classical physics. When observed under high-resolution scanners, the fractal's tiniest structures appear to communicate, with changes at the quantum level rippling instantaneously to the macroscopic scale. This isn't just self-similarity, it's a single, unified system operating across magnitudes from kilometers down to nanometers. The implications are staggering. Some physicists speculate the fractal could be a naturally occurring quantum computer, its nested structure acting like a cosmic circuit board. In lab experiments, quantum computers use qubits particles that exist in multiple states at once to perform calculations exponentially faster than classical machines. The quantum fractal's geometry suggests something similar. Its branching pathways might form natural qubits with entangled particles distributed across its layers, processing information through sheer structure. If true, this wouldn't just be a curiosity, it would be proof that the universe computes, weaving algorithms into the fabric of reality itself. Then there's the mystery of its origins. Fractals this precise don't form by accident. One theory points to the fractal's location, nestled near a pulsar emitting rhythmic gravitational waves. These waves, pulsing like a drummer's beat, could have tuned the surrounding plasma during the fractal's formation, sculpting it into this hyper-ordered state. Others suggest a more exotic catalyst, a brief encounter with a higher dimensional object, whose geometry imprinted onto our three-dimensional space like a shadow. But the most tantalizing possibility is that the fractal isn't static. Observations show its branches subtly shift over time, reconfiguring in patterns that resemble error correction, as if it's optimizing itself. Whether a frozen moment of cosmic computation or a living lattice of quantum logic, one thing's certain: the quantum fractal blurs the line between math and matter, challenging us to rethink what's possible when nature decides to show its work. And as we unravel its secrets, the Sombrero Galaxy whispers yet another riddle, a star that doesn't just burn but dreams, its light flickering with the rhythm of a sleeping mind. Dust in space is supposed to behave predictably, drifting lazily along gravitational currents, settling into star-forming nurseries or spiraling into the maws of black holes. But in the Sombrero Galaxy, one particular cloud laughs in the face of these cosmic rules. The gravity-defying dust doesn't drift or fall, it climbs. Like smoke rising against the wind, this eerie formation floats stubbornly away from the galaxy's core, its particles resisting the pull that should have dragged them inward eons ago. What makes this dust so rebellious? Ordinary interstellar dust is little more than microscopic flecks of carbon and silicates, pushed around by radiation pressure or magnetic fields. But this cloud moves with purpose, its trajectory too deliberate to blame on random forces. Spectrographic analysis reveals another oddity. The dust grains aren't just defying gravity, they're accelerating, as if some unseen hand is pulling them upward. The leading theory involves dark matter, that mysterious, invisible substance thought to make up most of the universe's mass. If a dense filament of dark matter threads through this region, its gravity could be counteracting the galaxy's pull, creating a sort of cosmic tug of war where the dust is caught in the middle. But there's a problem with that explanation. Dark matter's gravitational influence, while pervasive, is diffuse. It doesn't usually create sharp, localized effects like this. The dust's motion suggests something more targeted, almost like it's repelled by an anti-gravity force. Some researchers point to quantum vacuum effects, where the sheer emptiness of space itself might generate minute repulsive forces. Others wonder if we're seeing the fingerprints of modified gravity, a tweak to Einstein's equations that could explain the dust's defiance without invoking dark matter at all. Then there's the dust's composition. These particles aren't the usual sooty carbon blobs. They're laced with exotic metals like ruthenium and osmium, elements typically forged in supernova or neutron star collisions. Their surfaces are oddly smooth, as if polished by some interstellar process we've yet to understand. Could they be coated in a theoretical substance like mirror matter? a hypothetical twin to ordinary particles that interacts only weakly with known physics? Or are they cosmic shrapnel from an ancient cataclysm, propelled upward by the shockwave of a long-forgotten explosion? The most haunting possibility is that we're witnessing something entirely new, a force beyond our current models. Just as magnetism once baffled scientists, this dust could hint at uncharted physics, a fifth fundamental force lurking in the shadows of the cosmos. Until we unravel its secrets, the gravity-defying dust remains a quiet rebellion against the universe's rules, a reminder that even the smallest particles can hold the biggest mysteries. Floating in the shadow of a gas giant within the Sombrero Galaxy, an object gleams with an otherworldly brilliance: the crystal moon. This isn't just a rocky satellite peppered with mineral deposits. It's a sphere the size of Earth's moon, carved entirely from solid crystal, its surface so flawless it reflects starlight like a cosmic disco ball. When nearby suns kiss its edges, the entire structure erupts into a kaleidoscope of refracted light, casting prismatic rainbows across interstellar space for thousands of kilometers. The moon's origins are as enigmatic as its beauty. Most crystalline structures in space form under extreme pressure, like diamond rain inside gas giants, but a free-floating orb of this purity defies conventional geology. The leading theory suggests it began as a superheated magma moon, rich in silicon and oxygen, that cooled with impossible slowness over billions of years. Without dust or asteroids to disrupt its surface, its molten crust crystallized into a single, unbroken lattice, a planetary-scale gemstone forged by patience and perfection. But there's a catch: crystallization on this scale should have created internal fractures as it cooled. Yet scans reveal no cracks, no flaws, just seamless geometric perfection from core to surface. Then there's the light show. The crystal moon doesn't just reflect light, it multiplies it. Its internal structure acts like a celestial prism, splitting every photon that enters into cascading spectra. When a pulsar's beam sweeps across it, the moon projects intricate patterns resembling stained glass windows onto neighboring gas clouds, a phenomenon astronomers have dubbed cosmic cathedraling. Some wavelengths even emerge brighter than they entered, as if the crystal amplifies certain energies. This has led to wild speculation about its potential as a natural energy lens, perhaps even a prehistoric alien megastructure designed to focus starlight for propulsion or communication. But the real mystery lurks beneath the surface. Seismic scans conducted by bouncing lasers off the moon reveal hollow chambers within, their walls lined with crystalline growths that vibrate in harmonic resonance when stellar winds pass overhead. These chambers aren't random cavities. Their placement follows Fibonacci spirals, suggesting some form of acoustic or energetic purpose. Could they be natural resonance chambers, amplifying specific cosmic frequencies? Or the fossilized remains of a technology that once harnessed sound as a power source? The crystal moon stands as a testament to nature's capacity for artistry. Whether a freak geological wonder or something more deliberate, it challenges our notions of how matter organizes itself in the void. And as its fractured light dances across the cosmos, it whispers a tantalizing truth: sometimes the universe doesn't just create worlds. It sculpts masterpieces, stretching like an invisible seam across the Sombrero Galaxy. The dark matter filament weaves through the cosmos, a thread so delicate, so ghostly, it eluded detection for centuries. Unlike the glittering stars and glowing nebulae that dominate telescopes, this structure betrays its presence only through subtle tugs on the fabric of space-time. It's a cosmic spider's silk, spun from the universe's most enigmatic substance, dark matter, the unseen scaffolding that holds galaxies together. Scientists first pieced together its existence not by seeing it, but by noticing what it does. Stars near the filament move slightly faster than they should, their trajectories bending as if tugged by an unseen hand. Gravitational lensing, the warping of light around massive objects, reveals further clues. Distant galaxies viewed through this region appear stretched and twisted, their images smeared into arcs by the filament's invisible gravity. It's like watching heat ripple above a road, a distortion that hints at something far stranger beneath the surface. The filament structure defies ordinary matter. While gas and dust clump into clouds or spiral into disks, dark matter arranges itself into vast, intricate webs. This particular thread stretches over 20,000 light-years, connecting two massive galaxy clusters like a hidden highway. Theoretical models suggest such filaments are the universe's backbone, channeling dark matter and gas into the nodes where galaxies form. Without them, the cosmic web, the large-scale structure of the universe, would collapse into chaos. What makes this filament unique is its density. Most dark matter is diffuse, its gravity faint and spread across wide volumes. But here, the substance is concentrated into a narrow ribbon. Its pull strong enough to sculpt the motion of nearby stars. Some researchers speculate it could be a fossil from the early universe, a relic of the primordial fluctuations that seeded all structure. Others wonder if it's a snapshot of dark matter's cold nature, moving slowly enough to clump into fine details rather than smearing out like warm putty. The real breakthrough came when astronomers mapped the filament's shape using a technique called weak gravitational lensing statistics. By analyzing the subtle distortions of millions of background galaxies, they reconstructed its silhouette, a shadowy tendril snaking through the galaxy. The data revealed something even more startling. The filament isn't static. It vibrates, resonating with the gravitational echoes of ancient collisions, its oscillations hinting at properties we've yet to fully understand. This filament isn't just a curiosity, it's a key to decoding the universe's hidden architecture. If dark matter makes up 85% of all matter, then structures like this are the rule, not the exception. They dictate where galaxies bloom, how they cluster, even the fate of the cosmos itself. And as we trace this ghostly thread deeper into the Sombrero's heart, it pulls us toward an even greater mystery, a void where the laws of physics seem to unravel entirely. At the farthest edge of the Sombrero Galaxy, where the light of stars grows faint and the dust of creation thins to near nothingness, there exists a place that shouldn't be, a pocket of emptiness astronomers call the echoing void. Unlike the black silence of ordinary space, this region doesn't just absorb signals, it returns them, bouncing back radio waves and laser pulses with a delay that defies the laws of physics. Send a message into this abyss and seconds, sometimes hours later, it comes back to you, unchanged but impossibly late, as if the void itself is whispering your words back across time. The phenomenon was first discovered by accident. A team mapping the galaxy's outer reaches fired a radar pulse toward what appeared to be an unremarkable patch of darkness. When the echo returned 12 seconds later, twice the expected round-trip time for the measured distance, they assumed their instruments were faulty. But the anomaly repeated again and again with different telescopes, different frequencies. The void wasn't just distant, it was stretching signals, holding onto them before reluctantly letting go. The leading theory involves space-time itself behaving strangely here. Einstein's equations allow for regions where gravity warps the fabric of the universe so severely that even light takes a detour-like sound echoing in a canyon, but with the canyon walls made of twisted dimensions. Some models suggest the void might be a knot in space-time, a place where the usual rules of distance and duration tangle into loops. Signals entering it could be traveling extra laps through these hidden folds before emerging, explaining the delay. It's as if the universe in this one quiet corner has developed a stutter. Then there's the wilder possibility, extra dimensions. String theory proposes that our cosmos might be floating within a higher dimensional space, like a sheet of paper suspended in a vast room. If the echoing void sits near a crease in that sheet, a fold where higher dimensions press close, signals might briefly slip into these unseen realms before re-emerging into our familiar universe. The delay could be the time it takes for the energy to navigate this detour through hyperspace, but not all explanations reach for exotic physics. A vocal minority of researchers argue the void might be something more mundane, a dense, invisible cloud of ultra-cold particles, perhaps a new form of quantum matter that slows and scatters electromagnetic waves without absorbing them. Imagine shining a flashlight through thick fog. Light bounces off water droplets, diffusing and delaying the beam. In this case, the fog could be made of hypothetical actions or other dark matter candidates, their interaction with light just subtle enough to escape detection until now. The most unsettling detail, though, isn't the echo. It's the consistency. Delays vary wildly from milliseconds to hours with no discernible pattern. Yet the signals always return pristine, unaltered by noise or distortion, as if the void is carefully preserving them. This rules out chaotic scattering. Whatever's happening here is precise, almost methodical. Some astronomers have even joked about the cosmic voicemail theory, that we're not detecting an anomaly but a system, one designed to store and replay messages. Whether a quirk of gravity, a window into unseen dimensions, or something far stranger, the echoing void challenges our most basic assumptions about the nature of space and communication. It's a reminder that even emptiness can hold secrets, and that in the Sombrero Galaxy, silence sometimes speaks loudest of all. As we turn our gaze away from this whispering abyss, the next anomaly pulses into view, a star that doesn't just shine but breathes, its light swelling and fading with the rhythm of a living thing. On the surface of a barren moon orbiting a gas giant in the Sombrero Galaxy, a wound in the rock refuses to stay open. This is the self-healing crater, a gaping depression nearly 50 kilometers wide that behaves less like a static scar and more like living tissue. Most impact craters remain unchanged for billions of years, their edges slowly eroding under micrometeorite rain. But this one regrows. Satellite imagery over the past century shows its jagged walls gradually smoothing, its floor rising like bread dough, filling in the void as if tugged by invisible hands. The first clue to this anomaly came when probes detected strange seismic echoes beneath the crater. Instead of the random tremors typical of cooling rock, the moon's interior hummed with rhythmic vibrations, a low-frequency pulse that seemed to guide the repair process. Spectrographic scans revealed even more peculiar details. The reborn rock wasn't just debris sliding back in. Its crystalline structure mirrored the surrounding bedrock perfectly, as if the moon's crust was knitting itself back together atom by atom. Geologists initially pointed to tidal forces as the culprit. The moon's orbit around its gas giant creates intense gravitational flexing, which can heat the interior and soften rock. But calculations showed these forces couldn't account for the crater's precision. The repair isn't chaotic, it's programmatic, with fractures sealing in geometric patterns that suggest some form of stress redistribution. One theory proposes the presence of memory alloys in the moon's crust, metals that return to predetermined shapes when heated or stressed. On Earth, we use such materials in everything from eyeglass frames to spacecraft antennas. But for an entire moon to behave this way, that would require alloys on a planetary scale, woven into the bedrock like cosmic stitching. Then there's the wild card, nanoscale self-assembly. Microscopic particles in the moon's soil might be acting like tiny construction workers, rearranging themselves into stable structures when disturbed. Certain clays on Earth exhibit similar properties on a small scale, healing cracks when exposed to water. Without liquid or atmosphere here, though, the process would need another catalyst, perhaps the seismic pulses themselves, acting as a sort of sonic scaffolding to guide the particles back into place. But the most unsettling detail isn't how the crater heals, it's why. Natural systems don't waste energy on perfection unless there's a function. Some researchers speculate the moon might be part of a larger, interconnected system, where impacts trigger a repair protocol to maintain stability across the entire body. Others whisper about directed panspermia, the idea that life or its building blocks could be deliberately seeded across the cosmos. If the moon's crust contains engineered repair mechanisms, could they be the work of some ancient galaxy-spanning civilization ensuring their celestial architecture endures? The self-healing crater stands as a testament to nature's or someone's ingenuity. Whether a quirk of geology or a relic of cosmic engineering, it challenges our assumptions about how worlds endure in the unforgiving vacuum of space. And as we watch this lunar wound slowly seal itself shut, we're left to wonder, if a crater can heal, what other miracles might the Sombrero Galaxy be hiding? The chromatic storm rages across the upper atmosphere of a distant gas giant in the Sombrero Galaxy, a swirling vortex of color so vivid it looks like a nebula caught in a hurricane. Unlike Jupiter's great red spot or Saturn's polar hexagon, this storm doesn't settle into a single hue. It shifts, cycling through impossible shades every few hours, neon violet bleeding into molten gold, then deepening to an electric cyan that pulses like a living thing. These aren't the gentle gradients of Earth's auroras, they're abrupt, searing transitions, as if someone is flipping a cosmic switch behind the scenes. What makes this spectacle even stranger is the physics behind it. Atmospheric storms typically derive their colors from chemical compounds: ammonium sulfide for Jupiter's yellows, methane for Neptune's blues. But spectrographic analysis of the chromatic storm reveals no known molecules in sufficient concentrations to explain its palette. Instead, the light signatures suggest the presence of exotic particles, ones that absorb and emit energy at wavelengths beyond our periodic table's reach. Some researchers point to quark-gluon plasmas, a state of matter so extreme it hasn't existed naturally since the first microseconds after the Big Bang. Others speculate about chromatic matter, a theoretical form of particle that interacts selectively with specific colors of light, effectively filtering the storm's appearance like a cosmic mood ring. Then there's the storm's structure. Most planetary vortices are chaotic, their edges frayed by turbulent winds. This one maintains geometric precision, its swirling bands arranged in concentric circles that tighten and loosen like a celestial iris. High-resolution scans reveal filaments of superheated plasma threading through the clouds, forming patterns that resemble circuitry, a lattice of energy channels that might be steering the color changes. The leading theory suggests the storm is tapping into the planet's magnetic field, using it as a conductor to rearrange particles into fleeting, unstable configurations. Imagine a kaleidoscope powered not by glass and mirrors, but by the raw forces of electromagnetism and quantum uncertainty. But the most haunting detail isn't the colors, it's the silence. Storms of this magnitude should roar across the electromagnetic spectrum, blasting radio static as charged particles collide. The chromatic storm is eerily quiet, its shifts occurring without the typical crackle of atmospheric lightning or the hiss of ionized winds. It's as if the energy involved isn't dissipating into the surroundings, but being contained or even harnessed. Could this be a natural particle accelerator, a place where the universe experiments with states of matter we've never witnessed? Or does the storm's silence hint at something more deliberate, a process fine-tuned by forces we've yet to comprehend? The chromatic storm defies every convention of planetary science. Whether a window into undiscovered physics or a masterpiece of cosmic serendipity, it proves that even the most violent phenomena can hide an unnatural beauty. And as its colors continue their hypnotic dance, they paint a humbling truth across the void that the universe's palette is far richer, far stranger than we ever imagined. Among the swirling arms of the Sombrero Galaxy, two rings dance in perfect harmony, locked in an orbital embrace so precise, it defies the chaos of space. Known as the binary rings, these colossal structures circle their parent star like interlocking wedding bands, each one a flawless hoop of unknown material stretching millions of kilometers across. What makes them extraordinary isn't just their symmetry, it's their defiance of celestial mechanics. Rings like these shouldn't stay intact under the star's gravity, let alone maintain perfect alignment with one another. Yet here they are, untouched by time, spinning in eerie unison as if guided by an invisible hand. At first glance, they resemble fragments of a Dyson ring, a hypothetical megastructure designed to harness a star's energy by encircling it with orbiting platforms. Theoretical designs for such rings suggest they'd need artificial stabilization to avoid collapsing into the star or flying apart. The binary rings, though, show no signs of external support. Their orbits are geometrically perfect, their positions adjusted by some unseen force that counters gravitational tugs from nearby planets. Telescopes have even detected microscopic corrections in their paths, tiny, thruster-like nudges that keep them equidistant at all times, as if programmed. Then there's the material. Spectral analysis reveals the rings aren't made of rock or ice, but of a hyper-reflective alloy laced with metals like tungsten and rhenium, materials prized for their heat resistance and strength. Stranger still, their surfaces show no meteorite pitting or space weathering. Either they're impossibly young or something is actively repairing them. The leading natural theory proposes they're the remnants of a shattered super-Earth, its debris forged into rings by a passing black hole's tidal forces. But even that can't explain their synchronized motion or their unnatural longevity. The resemblance to theoretical Dyson designs is uncanny. Freeman Dyson himself once speculated that advanced civilizations might build segmented rings to capture stellar energy, partial versions of the classic Dyson sphere. Could these rings be a prototype, a test run by some ancient culture? Skeptics argue that nature occasionally produces coincidental geometry, like Saturn's hexagon or the rectangular icebergs of Earth. But the ring's stability tips the scales toward something more deliberate. Perhaps the most haunting detail is their silence. Unlike comet trails or asteroid belts, the binary rings emit no dust, no plasma, no thermal signatures, just cold, mirrored surfaces reflecting starlight back into the void. They don't even cast shadows on one another, their orbits too perfectly aligned to interrupt the light. Whether a cosmic coincidence or a message in metal, they stand as a testament to the Sombrero Galaxy's boundless capacity for wonder. And as their silent dance continues, we're left to wonder, are we looking at the ruins of a forgotten project or the blueprint of a future we've yet to build? The next anomaly offers no such ambiguity. It doesn't just defy physics, it laughs in its face. A star that pulses not with light but with sound, vibrating the fabric of spacetime itself. In the depths of the Sombrero Galaxy, where most nebulae drift like silent ghosts, one structure refuses to stay still: the living nebula. This colossal cloud of gas and dust doesn't just shimmer with starlight. It breathes, expanding and contracting in slow, rhythmic pulses that mimic the rise and fall of a living chest. Over decades of observation, astronomers have watched its tendrils stretch outward, then coil back inward, as if the nebula itself is drawing sustenance from the void. The cycles aren't random. They follow a pattern too precise for turbulence, too deliberate for chance. At the heart of this phenomenon lies a mystery: what's powering the motion? Most nebulae are shaped by external forces, stellar winds, supernova shocks, or the gravitational pull of nearby stars. The living nebula, though, seems to move itself. Spectroscopy reveals no nearby energy sources strong enough to explain the expansions, no hidden neutron stars or black holes tugging at its edges. Instead, the nebula's interior hums with chemical activity, its molecular clouds churning in self-sustaining cycles. Certain regions glow brighter during contractions, as if energy is being released in sync with the breathing, a clue that the structure might be recycling its own material, like a cosmic lung exchanging gases. This has led to a radical theory. Could the nebula be alive, not in the earthly sense of DNA and cells, but as a macro-scale organism thriving on principles we've yet to understand? Proponents point to the complex organic molecules detected within it, polycyclic aromatic hydrocarbons and amino acid precursors, the same building blocks that sparked life on our planet. Under the right conditions, these compounds might form self-replicating structures, networks of reactions that store energy and adapt to changes in their environment. Imagine a biochemistry not bound by planets but unfolding across light years, using plasma and dust as its medium. Skeptics, however, argue for a more mundane explanation. The nebula's pulsing could be driven by a feedback loop between radiation and magnetism. As starlight heats certain pockets of gas, they expand, weakening local magnetic fields. This allows more radiation to penetrate, further heating the gas until pressure overcomes gravity, triggering an expansion phase. Then, as the gas cools and contracts, the magnetic fields strengthen again, creating a natural oscillation. It's a celestial thermostat cycling between states without any life required. Yet even this fails to explain the nebula's most haunting feature, its memory. Observations show it adjusts its rhythm in response to passing stars or shock waves, learning from disruptions to maintain its pulse. Some researchers compare it to a slime mold's ability to solve mazes, a primitive form of problem solving emerging from simple rules. Others see echoes of Earth's biosphere, where feedback loops between organisms and their environment create planet-wide homeostases. Could the living nebula be a glimpse of how life operates on galactic scales? Or is it merely a mirror reflecting patterns we're wired to recognize as familiar? Whatever the truth, this shimmering enigma blurs the line between physics and biology, challenging us to expand our definition of what life might look like in the cosmos. And as its gaseous tendrils continue their slow, rhythmic dance, they whisper a tantalizing possibility that the universe may not just contain life but breathe it. Amid the cosmic ballet of the Sombrero Galaxy, there's a spectacle that seems frozen in time, a jagged arc of glowing plasma stretching across the void like a crack in reality itself. This is the frozen lightning, a bolt of cosmic electricity suspended mid-strike, its tendrils locked in a perpetual dance of energy and magnetism. Unlike earthly lightning, which flickers and vanishes in milliseconds, this structure has endured for centuries, defying the universe's relentless push toward chaos. At its core, the frozen lightning is a filament of superheated plasma, a searing blend of ionized particles whipped into a frenzy by temperatures rivaling the sun's surface. Normally, such a structure should explode outward, its energy dissipating into the cold vacuum. Yet here, the plasma holds its shape, constrained by an invisible cage of magnetic fields so intense, they've effectively fossilized the lightning in place. Imagine a river of fire trapped inside a glass tube, its fury contained by forces we can't see. The secret lies in the lightning's surroundings. This region of the Sombrero Galaxy thrums with tangled magnetic fields, woven into knots by the gravitational tug of nearby neutron stars. These fields act like cosmic puppet strings, pinning the plasma in place while allowing it to glow with undiminished intensity. It's a delicate balance. The magnetic pressure must exactly counteract the plasma's desire to expand, a feat akin to suspending a thunderstorm in a bottle. But there's another wrinkle. Plasma this hot should cool rapidly, its particles losing energy as they radiate light and heat into space. The frozen lightning, though, shows no signs of fading. Spectrographic readings reveal a steady stream of high-energy particles feeding into the structure, as if it's plugged into some unseen cosmic battery. One theory suggests the lightning is rooted in a pair of colliding stellar wind streams of charged particles blasting from nearby stars. Where these winds clash, they could be generating a standing shockwave, a perpetual energy source that keeps the plasma alive. Then there's the shape. Lightning bolts on Earth fork unpredictably, following the path of least resistance. This one forms a near-perfect fractal spiral, its branches repeating in mathematically precise iterations. Some researchers speculate the pattern emerges from resonant frequencies in the surrounding magnetic fields, vibrations that tune the plasma like a vibrating string. Others wonder if the structure is a cosmic-scale Lichtenberg figure, the branching scars left by high-voltage discharges, frozen in time by the galaxy's unique conditions. The frozen lightning isn't just a scientific curiosity, it's a laboratory for extremes. Studying it could unlock secrets about plasma containment, a challenge that stymies fusion research on Earth. It might even hint at how energy flows through the universe's most chaotic environments. Yet for all our theories, the structure remains stubbornly enigmatic, a reminder that even the most familiar phenomena can become alien when the cosmos decides to bend the rules. And as this electric scar crackles silently against the darkness, it points the way to the Sombrero Galaxy's final mystery, one that doesn't just defy explanation, but seems to rewrite the laws of physics entirely. Hovering at the edge of the Sombrero Galaxy's luminous core, suspended in the inky blackness like a phantom of the deep, drifts an apparition that seems plucked straight from Earth's oceans, the cosmic jellyfish. Its translucent body pulses with bioluminescent energy, while tendrils of ionized gas trail behind it, stretching hundreds of thousands of kilometers into the void like ghostly fishing lines. The resemblance to its earthly counterparts is uncanny. The same bell-shaped mantle, the same rhythmic contractions, even the same eerie grace as it glides through the stellar currents. But this is no sea creature, it's a structure of plasma and magnetic fields, a celestial entity that challenges our understanding of form and function across the cosmos. What makes this cosmic mimicry so unsettling is its sheer improbability. Jellyfish evolved their shape to navigate Earth's oceans, a fluid environment with specific pressures, temperatures, and predators. Space, by contrast, is a vacuum where forces like gravity and electromagnetism dominate. Yet here, against all odds, nature appears to have sculpted identical contours. The bell of the cosmic jellyfish isn't made of gelatinous tissue, but of superheated gas constrained by swirling magnetic fields, its pulsing motions driven not by muscles, but by the explosive energy of nearby stars. The tendrils, their filaments of plasma, electrified by particle winds and twisted into spirals by the galaxy's rotation. Even the bioluminescence is an illusion, radiation from anglerfish-like stars hidden within the structure, their light filtered through nebular gases to create that haunting glow. This raises a profound question. Are the similarities mere coincidence or evidence of universal patterns? Scientists call this phenomenon convergent evolution, when unrelated systems independently arrive at the same solution. On Earth, dolphins and ichthyosaurs developed near-identical streamlined bodies despite evolving millions of years apart. In space, could the laws of physics favor certain shapes, whether in organic or astrophysical contexts? The jellyfish's form optimizes energy efficiency. Its bell minimizes drag or, in space, particle resistance, while the tendrils maximize surface area for absorbing cosmic rays. One theory suggests that plasma, under specific magnetic conditions, naturally self-organizes into these shapes, meaning jellyfish-like structures could be as common in galactic nurseries as they are in Earth's tides. But there's a darker, more tantalizing possibility. What if the resemblance isn't accidental at all? The jellyfish floats near a region rich in complex organic molecules, the same compounds that spawned life on our planet. Could this be a sign that life's building blocks scattered across the cosmos inevitably stitch themselves into familiar patterns? Or does the structure hint at something more radical, that biology and astrophysics aren't separate domains, but different expressions of a deeper, universal order? Imagine if DNA's double helix, snowflake symmetry, and spiral galaxies all share a hidden geometric language. The cosmic jellyfish then becomes a cryptic stanza in that poem. As telescopes probe deeper, they've uncovered an even stranger detail. The jellyfish's tendrils aren't passive. They flick and curl in response to gravitational waves, as if sensing vibrations in spacetime itself. Some researchers compare it to a cosmic antenna, its plasma filaments fine-tuned to frequencies we've yet to decipher. Others see traces of a natural supercomputer, a network where charged particles process information through their interactions. Whatever the truth, one thing's certain. In a universe teeming with wonders, the cosmic jellyfish reminds us that the line between the familiar and the alien is thinner than we ever dreamed. And as its luminous tendrils drift silently through the void, they leave us wondering, are we gazing at a quirk of physics or glimpsing a shadow of something far older, far wiser than the stars themselves? The cosmic jellyfish doesn't just mimic the shape of its earthly namesake, it pulses with an energy signature unlike anything else in the known universe. While most nebulae glow with the gentle diffusion of starlight or the chaotic fury of supernova remnants, this structure emits precise, rhythmic bursts of energy across the electromagnetic spectrum. Like a heartbeat recorded on an electrocardiogram, its pulses appear almost biological, rising and falling in cycles that defy the random noise of cosmic radiation. When astronomers first analyzed these emissions, they expected to find the usual suspects: synchrotron radiation from charged particles spiraling around magnetic fields, or thermal radiation from heated gas. Instead, the data revealed a bizarre hybrid. The jellyfish's bell radiates high-energy gamma rays in short, controlled bursts similar to the output of a pulsar, but without the telltale spin-down of a rotating neutron star. Meanwhile, its tendrils emit low-frequency radio waves in cascading waves, like the synchronized firing of neurons in a brain. This combination, gamma and radio, fury and finesse, has no natural counterpart in our catalogues of celestial phenomena. One theory points to magnetic reconnection, a process where twisted magnetic field lines snap and release explosive energy. On the Sun, this creates solar flares and coronal mass ejections. But the jellyfish's emissions are too orderly, too orchestrated. The gamma-ray bursts arrive in mathematically perfect intervals, separated by precisely 17.3 minutes, a cadence that persists unchanged for decades. It's as if the structure is tapping into some cosmic metronome, its energy output fine-tuned to a universal rhythm we can't yet hear. Then there's the speculative angle. Could these pulses be evidence of energy harvesting? The jellyfish floats in a region dense with charged particles streaming from nearby stars. Its tendrils, rich in ionized plasma, might act like cosmic fishing nets, siphoning energy from stellar winds and funneling it toward the bell. This wouldn't be so different from proposals for Dyson Swarm's hypothetical arrays of energy collectors around stars, except here, nature itself may have stumbled upon the design. The gamma bursts could be waste heat, vented after the structure extracts usable energy from the chaos. Skeptics argue this grants too much agency to natural processes, but the numbers are provocative. Calculations show the jellyfish's energy output matches predictions for a rudimentary stellar engine, a device theorized to harness a star's power for propulsion or computation. Even stranger is the radio emission pattern. The tendrils don't just broadcast noise, they modulate their signals, shifting frequencies in sequences that resemble prime number intervals. On Earth, we use similar patterns in cryptography and communication to distinguish artificial signals from natural ones. Could this be a natural quirk of plasma dynamics or something more intentional? SETI scientists have spent years decoding these radio waves, searching for embedded information. So far, no luck, just endless variations on a theme that feels almost but not quite designed. Perhaps the most haunting possibility is that the jellyfish isn't a structure at all, but a process. Some researchers compare it to a standing wave in water, where energy flows continuously without moving the medium itself. The visible form, the bell, the tendrils, might just be the shadow of something deeper, a self-sustaining loop of energy and matter, cycling through states we've yet to define. In this view, the jellyfish isn't harvesting energy, it is energy, a fleeting pattern in the cosmic fabric that's found a way to persist. As we unravel these mysteries, one thing becomes clear: the jellyfish challenges the boundaries between physics and something else. Whether a natural wonder or a glimpse of technologies beyond our own, it hums a silent reminder. The universe is far stranger than we imagine and far more inventive. And somewhere in its pulsing glow, there may be answers to questions we're only beginning to ask. The chromatic storm's unnatural hues aren't just a visual spectacle, they're a chemical puzzle written in light. Deep within its swirling bands, spectrographs have detected trace elements that shouldn't exist in a gas giant's atmosphere. Promethium, Einsteinium, even fleeting signatures of element 122, a substance so unstable it's never been synthesized on Earth for more than microseconds. These aren't the usual suspects of planetary chemistry. They're cosmic alchemy, forged in environments so extreme they rewrite the rules of atomic stability. Take promethium, a rare Earth metal that decays within years under normal conditions. Here it persists, its half-life seemingly stretched by the storm's churning magnetic fields. One theory suggests the particles are caught in a quantum stasis, their decay slowed by relativistic speeds as they spiral along magnetic field lines at nearly the speed of light. It's like watching a candle flame frozen mid-flicker, its chemistry defying time itself. Then there's Einsteinium, typically produced in nuclear reactors or supernova shockwaves. Its presence hints at a recent stellar cataclysm, nearby perhaps a neutron star merger that peppered the gas giant's atmosphere with exotic debris. But element 122 is the real enigma. Predicted by theoretical models but never observed naturally, this super-heavy isotope should collapse under its own atomic weight instantly. Yet the storm's inner vortices show spectral lines matching its predicted electron orbitals, however briefly. Some researchers argue these could be islands of stability, theorized regions where super-heavy elements persist longer due to precise proton-neutron balances. If true, the storm might be a natural particle accelerator, its turbulence creating fleeting conditions where the periodic table's edge gets pushed. The origins of these materials are even more contentious. Supernova can forge heavy elements, but their distribution is usually scattered across light years, not concentrated in a single storm. Alternative explanations range from the detritus of an ancient alien experiment, a failed attempt to synthesize new elements, to the remnants of a quantum singularity's evaporation, a black hole's dying breaths lacing the atmosphere with exotic matter. The most compelling natural theory involves a Thorne-Zitkow object, a hypothetical hybrid star with a neutron core nested inside a gas giant. If such an object once orbited here, its death throes could have seeded the storm with these rarities. Yet the storm doesn't just contain these elements, it arranges them. Filaments of promethium curl around Einsteinium veins like vines on a trellis, while super-heavy isotopes cluster in geometric lattices resembling crystalline alloys. This isn't random scattering, it's microstructure on a planetary scale, as if the storm's turbulence follows an unseen blueprint. Magnetic spectroscopy reveals patterns resembling Bose-Einstein condensate states of matter where particles synchronize into quantum harmony. Under Earth lab conditions, this requires temperatures near absolute zero. The storm achieves it in a maelstrom hotter than lava. What emerges isn't just a weather system, but a crucible. A place where the universe's rarest ingredients simmer under conditions we can't replicate, weaving chemistry into art. Whether a natural particle collider or something more deliberate, the chromatic storm forces us to confront an exhilarating truth. The periodic table might be larger, stranger, and more malleable than we ever dreamed. And as its alien palette continues to shift, it paints a humbling reminder: some laboratories are too vast for walls, and some experiments outlive their creators by eons. The singing asteroids' eerie harmonies didn't just captivate scientists, they reverberated through human culture, sparking creativity and controversy in equal measure. Within months of its discovery, musicians began transcribing its radio wave pulses into audible melodies, transforming cosmic vibrations into symphonies. The Berlin Philharmonic famously performed Celestial Resonance, a composition built entirely on the asteroid's 17-minute harmonic loop, stretching and layering its tones into an orchestral echo of the cosmos. Electronic artists, too, found inspiration in its rhythms. One Grammy-winning producer sampled its frequencies for a hit track, calling it the universe's most ancient beat. But the asteroid's influence went beyond music. Poets penned verses about its silent song, while immersive theater productions used its pulse as the heartbeat of interstellar narratives, blurring the line between art and astrophysics. Yet where artists heard muse, conspiracy theorists heard messages. Online forums erupted with claims that the asteroid's precise intervals matched numeric sequences from ancient Sumerian tablets, alleged proof of an alien breadcrumb trail left for humanity. One viral documentary argued the signals were coordinates pointing to a forgotten star system, while a pseudoscience bestseller insisted the asteroid was a dormant beacon, its song a countdown to some cosmic event. Skeptics dismissed these as pattern-seeking, the human brain's tendency to find meaning in randomness, but the theories persisted, fueled by the asteroid's uncanny resemblance to hypothetical alien communication methods proposed by SETI. Even NASA press releases couldn't quell the frenzy. When a scientist offhandedly called the pulses unnervingly musical, it became a rallying cry for UFO enthusiasts. The scientific community, meanwhile, grappled with the asteroid's cultural shadow. Astronomers found themselves fielding questions about extraterrestrial composers at press conferences, while peer-reviewed journals published tongue-in-cheek analyses of the musicality of plasma vibrations. One team at MIT even developed an algorithm to compare the asteroid's harmonics to Earth's folk music traditions, discovering unsettling parallels to Tibetan singing bowl meditations and Tuvan throat singing. It's not proof of aliens, the lead researcher clarified, but it's proof the universe loves a good groove. Perhaps the most unexpected impact was spiritual. New Age movements adopted the asteroid as a celestial metronome, synchronizing meditation practices to its pulse. Retreats offered cosmic sound baths where participants lay under speakers playing its frequencies, claiming the vibrations induced transcendent states. A viral wellness influencer even marketed a singing asteroid sleep aid, despite astronomers' reminders that the original signal was technically inaudible without augmentation. The asteroid became a Rorschach test for humanity, a blank slate onto which we projected our dreams, fears, and the timeless question, are we alone? By the time a probe finally reached the asteroid, its cultural footprint had outgrown its physical one. The mission's live stream broke viewership records, not for the science, but for the hope or fear of cracking its code. When the data confirmed its song was a natural magnetic resonance, the disappointment was palpable. Yet the asteroid's legacy endured. It reminded us that the cosmos isn't just a subject for textbooks. It's a canvas for imagination, a mirror reflecting our hunger for connection across the void. And as its silent frequencies continue to ripple through space, they carry a truth more profound than any conspiracy. Sometimes the universe's greatest gift isn't answers, but the questions that make us create. The hollow planetoid drifting through the Sombrero Galaxy isn't just an empty shell, it's a cosmic nesting doll. Its cavernous interior hiding possibilities that range from the breathtaking to the bone-chilling. Imagine cracking open this celestial egg to find not yolk, but an entire ecosystem thriving in the darkness. Far-fetched, not necessarily. On Earth, life clings to the most hostile corners, volcanic vents, Antarctic ice, even the crushing depths of the Mariana Trench. Inside this planetoid, protected from radiation and micrometeorites by its thick crust, subterranean oceans could slosh in perpetual twilight, their surfaces teeming with microbial colonies that evolved without sunlight. These organisms might metabolize minerals seeping from the walls or harness geothermal energy from the planetoid's core, creating a food web as alien as the void outside. Or perhaps the hollow space isn't natural at all. The planetoid's unnervingly uniform shell hints at precision engineering ancient buttresses or support beams disguised as geological formations. Scans revealing geometric echoes in the interior could point to megastructures, cavernous reactor chambers, long dormant propulsion systems, or even the skeletal remains of a Dyson swarm component, its solar collecting panels folded like the wings of a dead mechanical insect. Some theorists suggest the entire planetoid might be a colossal ark, its hollow belly once packed with cryogenically frozen organisms or cultural artifacts from a civilization that saw its star dying and launched its heritage into the void. The silence from within could mean the preservation systems failed or that whatever slept inside has yet to wake. Then there's the unsettling third option, that the hollow center isn't empty but filled with something we can't perceive. Dark matter, which makes up most of the universe's mass, doesn't interact with light or ordinary matter, yet its gravitational influence could theoretically condense into strange, intangible structures within the planetoid's heart. Alternatively, the interior might host a space-time anomaly, a pocket of warped dimensions where the laws of physics unravel. Probes sent inside could emerge distorted, their clocks out of sync, or vanish entirely, swallowed by a gateway to somewhere or someone else. The most haunting possibility, that we're staring at the universe's version of a locked door. The planetoid's flawless surface, its unnatural orbit, its resonant silence, these could be features, not bugs. A civilization advanced enough to hollow out a world might also know how to seal it, whether to protect what's inside or to protect the galaxy from whatever they imprisoned there. Until we dare to knock, the hollow planetoid will keep its secrets, a silent sphinx floating in the cosmic dark. From the phantom spiral's ghostly defiance of gravity to the time-dilation vortex's warping of reality itself, the Sombrero Galaxy has proven itself a cosmic hall of mirrors, where every mystery solved reveals three more lurking in the shadows. These 30 enigmas aren't just astronomical oddities, they're boundary stones marking the edges of our understanding. Take the binary rings circling their star with mechanical precision as if engineered by unseen hands, or the living nebula's rhythmic breaths that blur the line between gas cloud and organism. Even the humble singing asteroid, humming its eternal note, forces us to confront how much music might be woven into the fabric of the cosmos. What ties these phenomena together isn't just their strangeness, it's their audacity. The universe, it seems, delights in subverting expectations. The frozen lightning should have faded eons ago, yet its electric scar still crackles against the void. The hollow planetoid's empty interior defies every law of planetary formation, while the quantum fractal's mathematical perfection suggests the cosmos might be computing something beyond our comprehension. And let's not forget the chromatic storm, painting a gas giant in colors that shouldn't exist, or the cosmic jellyfish, a structure so hauntingly familiar it feels like the galaxy's inside joke. These aren't just puzzles for astronomers, they're invitations. Every flicker of the radio pulse beacon, every backward orbit of the rogue star cluster whispers the same thrilling question: what else is out there? The Sombrero Galaxy reminds us that discovery isn't about checking boxes. It's about stumbling into wonder, about realizing the universe is stranger, wilder, and more inventive than our textbooks dared to suggest. So which of these 30 mysteries lingers in your imagination? Is it the eerie synchronicity of the mirror comets gliding in lockstep like celestial ballerinas? Or the triangulum ships, their geometric flight patterns hinting at forces or intelligences we've yet to meet? Drop your favorites in the comments below and let's keep the conversation soaring. If today's journey through the cosmic weirdness of the Sombrero Galaxy left you hungry for more, hit subscribe, because the universe has endless secrets left to share and we're just getting started. Until next time, keep looking up and never stop wondering what's hiding in the starlight.